I was visiting Convict Lake last winter when I threw a rock on the frozen surface. Listen to this sound. It's so crazy. As the rock hits the frozen ice, it sends vibrations through the ice into the water, and those sound vibrations get bounced back and forth, making unusual patterns of sound. If you use a tight coil of copper wire, you can put out a candle flame and immediately bring it back to life. There are a few things going on here. Copper is one of the most thermally conductive metals, which means as I put it over the flame, it's taking away heat. This is also a tight coil, so it's depriving the flame of some oxygen. But as soon as you remove it, the flame gets heat and oxygen again and can reignite. But if you deprive it of too much oxygen and heat, it'll go out for good. We filmed a bubble popping in high speed. But before we get to that, have you ever thought about why bubbles pop? Water likes to stick to itself, so it can make a shell like a balloon. The bubble shell is holding in some air pressure, which is pushing back out on the bubble. When the shell gets poked or it gets too thin from evaporation, the bubble can't hold in the air pressure anymore and it breaks. But it has to pop around the air that was inside. So you can see in high speed that it doesn't just shrink down. It pops like the sphere of air inside is still there, because it is. And that's some science. This is what happens when you mix warm water with a mystery liquid. Can you guess what the liquid is? I'll give you a hint. It's in our atmosphere. It's nitrogen, but so cold it's in liquid form. The cloud forms because the liquid nitrogen is so cold that is below negative 320 degrees Fahrenheit, and the warm water causes it to boil super fast. So it becomes very cold nitrogen gas, which then condenses some of the water in the air out into tiny water droplets that you can see with your eyes and looks just like a cloud. These are bioluminescent waves in the ocean. I filmed them at the end of April in 2020 when a giant algae bloom hit San Diego. The algae bloom is called red tide and smells a bit like rotten sulfur. The glow of these waves is caused by a chemical reaction inside of dinoflagellates, which are a type of plankton. This kind of bioluminescence is a type of chemiluminescence, which is similar to the process that causes glow sticks to glow when you mix the chemicals together. Here are some surprising household items that fluoresce under a black light. This is laundry detergent. If you shine a black light on phone screens, most will show an unusual pattern. Duct tape, not so much. But tennis balls definitely fluoresce. Fluorescence is when you shine high energy light, like ultraviolet light, on an object, and it glows. It emits lower energy light, like green, yellow, blue light, or red light. A lot of paper and labels fluoresce too. This is my favorite object though. Some of the minerals in this rock fluoresce green, despite the fact that you can't see any green in the rock. That's cool. This is how to pour out a candle when it appears there's nothing in the glass. Pour a bunch of vinegar into baking soda and let it bubble. You've just created a bunch of carbon dioxide, which you can dip a cup in and very carefully fill up. Since carbon dioxide is more dense than air, you can pour it. The CO2 will push all the air out of the way, starving the fire of the oxygen it needs to keep burning. And as long as you have CO2 in your cup, you can keep pouring out the candle over and over. This is what happens when you put a rubber ducky or any rubber animal in liquid nitrogen. Liquid nitrogen is below minus 320 degrees Fahrenheit, so it takes elastic rubber and makes it brittle. This is a glass of water, this is a mystery liquid, and this is a violet laser. That means a laser with violet light. So when I shine the laser into the water, you can see a little bit of the line. The light is scattering off of water molecules. But when I shine it into the mystery liquid, that is different. Check that out. Can you guess what it is? This is tonic water. It contains an ingredient called quinine, which fluoresces blue when you shine an ultraviolet or violet light inside. This is not an animation. It's light in real life shining on a wall, visualizing sound waves. I made this setup that starts with a laser pointing down at a piece of mirror, taped to a balloon, stretched over a cup with the bottom cut off, and taped to a cone picking up the sound from a speaker. As I play a single note, a single wavelength of sound waves from the speaker, it vibrates the mirror, creating patterns of light on the wall. As I add more than one frequency, you start to see really cool patterns emerge. What you're seeing here is the really crazy, complex motions of the balloon vibrating from sound waves. It's like the way your eardrum moves and vibrates due to the motion of air as sound waves travel through the air.